guys, it's IDW, and today we are going to be going over how exactly I built this thing, which I explained in the sort of last video explaining what exactly this is. And for those of you who don't remember, this is basically a concept that I have used to make it so that you can have 8 cores on just one circuit. And yeah, so because of that, I'm going to be doing a build tutorial for the design right here. However, I said this a few seconds earlier, this is a concept, it is not actually a build. You could use any CLE ALU for this. You could even use one that is not torchless like this one is. But the amount of delay that you're going to add, bringing the inputs around into here, is going to be equal to the number of registers you want to have times the throughput. So you can, if you have less delay, then it's going to make it so that, or if you have a lower throughput, then it's going to make it so that you can have more registers for fewer amount of delay. So yeah. Anyways, so on to the actual build for this thing. Alright, so here we have our CLE ALU, and yeah, so all that you really need to have to do this is basically have an ALU that supports pipelining, and then you can just honestly just hook this stuff up really simply, because all we're really doing is we're just going to take the output and we're going to string it back into the input. Also, there's a weird thing with repeaters, which makes it so that every time the well, with delay line memory, it seems like if you add extra ticks, I'm no repeater expert, but if you add extra ticks, you get really weird data corruption, and I don't know what's up with that. Once again, I am not a repeater expert, but yeah. Additionally, in this circuit, there are actually, like right here, repeaters with multiple ticks of delay for synchronization that just couldn't get any better. So yeah, and because of that, that's why this is honestly something that I want other people to show off and, well, not really show off, but build a better design for. This is just a concept once again. So the next question that we have to answer is how many repeaters should we exactly put on this thing? And the answer is basically we're going to just use as many as we need to get 8 registers, or separate cores, or separate accumulators, whichever you like. So let's see, 1, 2, 3, 4, 5, 6, 7. Yeah, I thought it was 7. Anyways, so 7 plus 9 is 1, 2, 3, 4, 5. So we have 5 here, 6, 7, 8, 9, and that should be it. And we're also going to have, you can also put like a comparator here if you want to have like a clear register function on it, but yeah. Anyways, so now we just need to do this to all the other bits, and yeah, so we're basically going to be done. So let's just build it on the second bit next. I'm going to need to go down one. And we just need to drag this out here, plug it in there, 1, so that's 8, 9, 10, 11, 12, 13, 14, 15, 16. And that's the exact same as that one, perfect. Okay, just making sure that I'm doing the right thing. Never can be too careful with these sorts of things. Anyways, we're going to wrap around here, and then we're going to use World Edit to our advantage. Let's see, copy, paste, paste, whoops, paste, 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 and now we just need to add like a block down here onto all of these. Not sure why I didn't select that, but whatever. And then this thing should be fully functional. And yeah, so I'm sorry if a few of you were disappointed and thought I was going to build the entire thing, but as I said earlier, this isn't really the best design to actually build the entire thing with it, so yeah. I'm basically just going to be showing off exactly how to use this thing now, because now that we've actually built one, we really just need to make it so that it implements the 8 cores part. And the idea for that is basically each one of the registers that's effectively made in this delay line memory is going to be a, what's it called? Each one of them is going to be a accumulator CPU, and for those of you who don't know what an accumulator is, it's basically when you only have one register in your CPU, and your first input comes from memory, and it is part of your bit layout where the memory address of that, so yeah. A good example of a computer that does this is, I think it's the PDP-8 that has an accumulator, but yeah, so if you want to check out actual real computers that use accumulators, the PDP-8's a pretty old one, but once again, Redstone computers really are not only comparable to really old computers, so yeah. For instance, in a modern computer, you would absolutely never have an accumulator, so yeah. Anyways, so now we can just actually get the output. If we want to take some memory out of the registers and, or cores rather, we can just take it out through this repeater right here. And the reason that that's going to work is basically it's going to be outputting the signal that's at the entrance to the ALU at all times. So that means that if I wanted to do a function where I was going to take the value that's in one of the registers and I wanted to move it outside of it, then I would just have it at this time in the clock cycle. I would have it read out of here. As for the next input, that is the one that is independent, so that one is going to be facing in, and this is the one where your accumulator is going to come in through, and yeah. You have to make sure that your first value comes in at the first time, your second value at the second time, third at the third time, etc., etc., etc. And yeah. So another part of the concept, though, that I've thought of more recently than the initial design is having more than one of these, what's it called, delay line memory-based systems, so that you could have more than one register, and therefore not just have to have an accumulator like in this design. But yeah, so I haven't actually thought up of any sample architectures for this sort of CPU yet, but yeah. So that's just about it for the entire thing on this idea I've had. So I hope you guys have enjoyed. I hope you guys have fun implementing this if you're going to implement it. And yeah, I'll see you guys next time.